All right, my pre-cal superstars. So yesterday we covered what happens when we have an A or a D, where we have a stretch, some kind of stretch, or compression, or like at the end we finished with, we had a shift up or down, so it changed our midline or our baseline, as I've been calling it. Now what we're going to do is we're going to move on and see what happens when we start doing things in the X direction. So on the next page here, what we've got and the way to know you're on the right page in your notes is to say the effect of B and C on the parameters, all right? So what we're looking at here is now we're talking about things that are happening on the inside of the parentheses. All right, so first of all, I wanted to point out a couple of things. These B and C I'm talking about comes from when we're looking at this form of the equation here. The B would be something that I'm multiplying times the X, and the C is something that we're adding or subtracting to the X inside the parentheses. So again, this is going to be stuff that's going on inside the parentheses. So we're talking about horizontal things, either horizontal stretches or compressions, or horizontal shifts, and what we call those is phase shifts. So first let's start with B. So right down here, we've got a couple of examples where we're multiplying 2 times x over here for cosine, and then sine we've got 1/2 times x. Now, normally what we do is, right off the bat, we start by drawing our scale. But something that we need to take into consideration now is the period. Now, our period is the distance between peak to peak or trough to trough in our for our functions, for our wave functions. So we need to take into account how far apart those things are going to be before we start scaling. So first of all, what we want to do is realize that the normal period is 2 pi. So for all my trig functions so far, we've said that the period has been 2 pi. So cosine and sine, they always go from 0 to 2 pi. That gets us a full rotation, a full waveform, and then we go from there. Well, a new period comes into play right here when 2 pi is divided by b. So whatever this b is, we need to actually divide 2 pi by it so that we know what our new period is. So for this one, our b here is 2. So that means that for our new period, that's going to be equal to 2 pi divided by 2. So in this case, that's going to be pi. So our full waveform actually happens in pi. Okay? So since that's in pi, we can go ahead and scale it like we normally would. We'd go 1, 2, 3 to the right, and that would give us pi over 2. 1, 2, 3, and we get pi. 1, 2, 3, and there's 3 pi over 2. 1, 2, 3, and then there's our 2 pi. Okay, so that's all just like normal. Our y direction, we still want to skip 1, and then that'll give us 1, and then 2, and then 3, and then we'll go down here. -1, -2, and -3. Now our cosine function always starts, when we start at 0, remember that one always starts at 1, so that's not going to change. But now that our period is pi, instead of ending at 2 pi like we normally would, we would say, okay, well, we're going to end at 1 again at 2 pi. We're actually going to end again at pi. So our beginning is at 0, and our ending is now going to be at pi. So we're going to start by doing both of our endpoints, then we're going to go from there. So once we have our endpoints where we know cosine starts at 1 and ends at 1, then what we'll do is we now know that pi over 2 is going to be the halfway point. Now in a normal cosine function, the halfway point ends up at -1. And so that would be usually where we're at pi, because that would be the halfway point between 0 and 2 pi. That's usually at -1. But now that shifts over to the midpoint between these two. So halfway between them is pi over 2. So that's where my function gets down here to -1. That's going to be my midway point, and that's where it's going to be at -1. In between there, the midpoint between where I started and my real midpoint, so halfway between the halfway point, so essentially 1/4 of the way, would be where we cross 0. And so since our scale only goes by thirds, we kind of have to go by like 1.5 here. So it would be right here in the middle, and then that would be where the other one would go here. And that would be, that's pretty much our function right there. It's really compressed. We have to like make sure it's curved. Okay, there. And it would look something like that. Now compare that to what this regular cosine function looks like right here. See, we start at 1 and we end at 1. That's still the same. But if you look, we go from 0 to 2 pi on our regular one, and on this one we only go from 0 to pi because that's our new period. All right? So then halfway between on our regular one, 0 and 2 pi would be pi, and that's where it's -1. So look, halfway between 0 and pi, our new period, is -1. So that's where our phase shift comes in, and then our other halfway points become those ones. If we want to get really technical here, we can actually say that these points, because the halfway points here, this would be 3 pi over 4, and then this one would be pi over 4. If we want to really get technical, we can go ahead and put that in there. But that's pretty much it. Now our range, R, still just going to be the regular, same old. This is going to be from -1 to 1. There was no amplitude change, so that's still going to be the normal range. All right, now let's take a look at this one. Y equals sine 1/2 x. So now my b in this case is going to be 1/2. So since b is 1/2, we'll go ahead and our new period is going to be 2 pi divided by 1/2. Okay, when you divide by a fraction, it just flips and multiplies. So it's going to be actually 4 pi. So now instead of our period being a regular 2 pi, now it's 4 pi, and that's why we gave ourselves lots of room on this one, because it's going to be really wide. So we need to make sure we scale this right. 1, 2, 3 is going to be pi over 2. 1, 2, 3 is going to be pi. 1, 2, 3, 3 pi over 2. 1, 2, 3, that's 2 pi. And then we got to keep going now. 1, 2, 3, that's going to be 5 pi over 2. 1, 2, 3 would be, what would that be? 3 pi? Yeah, 3 pi. 1, 2, 3 would be now 7 pi over 2. And then we got to get all the way to 4 pi. So that'd be 1, 2, 3. There's our 4 pi right there. Okay, so now again, oh wait, almost forgot the scale. 1, 2, 3. And we'll go down, -1. And then we got -2 and -3. All right, so now, sine starts at 0. Sine always starts and ends at 0, unless we have some kind of like up and down, but we're not worried about that right now. So it starts and ends at 0. So I'm going to start at 0, and then where it ends is my period. My period's 4 pi, so I got to go all the way to 4 pi. That's where I end again. Okay? So with sine, it always starts at 0 and ends at 0. Then in the middle, sine actually hits 0 as well. So my midpoint between these two would be 2 pi, so that's where it's going to be in the middle. Now, from here, stay with me. From here, sine always goes up first, and then it goes down second. So when it goes up here, the midway point between 0 and 2 pi, or halfway, is going to be up at 1. So that's why pi right here is my midpoint, and it's going to be up at 1. Now my midway point between 2 pi and 4 pi, that's where it's going to be coming down, so that's where it's going to go down to -1. Halfway between 2 pi and 4 pi is actually 3 pi. So that's going to go right there. So it's all stretched out like that. And that's how that one works. Our range, again, same thing. We didn't do anything to the amplitude. It still only goes from -1 to 1. So it's going to be -1 to 1, just like that. Now, let's see what happens when we have a really weird B. So we got some interesting things that happen there. So if we flip over the page, up here at the top, we've got these, our B in these cases are now, have pi's in them. So right here, this is cosine. So this is going to be, our B is cosine. So when we find our period, it's still 2 pi divided by that B value. So that's going to be pi. Our pi's are going to cancel, and our period actually ends up being 2. So this is why we're going to be careful about finding our period before actually scaling here. Because there's actually something I wanted to point out. There's a reason why we picked 6 squares for every pi, right? 1, 2, 3, 4, 5, 6 squares was pi, right? Well, pi, right? Pi is 3.14, right? Or about 3, right? So if that's about 3, it is pretty close, so we'll call it good. Then if we go ahead and say instead that every step here, every other step here was just 1, so we skip 1, that's 1, skip 1, that's 2, skip 1, this would be 3 instead. We skip 1, that would be 4, skip 1, that'd be 5, and we skip 1, that'd be 6. Look at that. Now we can deal with a period of 2. Because now, as you can see, we've changed these into just 1, 2, 3, 4, 5, 6. Just like we do with the y-axis. So that's how we can kind of reconcile when that happens like this, where that pi kind of goes away. We kind of just like fudge the 0.14 part out and just say, okay, well now they're all just going to be every other one. It's just like a half for each little piece. And so it kind of works out nice that way. Oh, forgot to write my period up there. Okay, cool. So now we'll go ahead and graph it the same way that we've been doing the other ones. My period's 2, so I want to make sure that I include my whole wave from 0 to 2. So I got to make sure I start at the right place. Cosine always starts at 1. So I'll start at 1. So it's 0. We're going to be at 1 just like that. Okay. Now my end point is actually going to be 2. So I'm going to put this guy here at 2. Okay, that's my full wave. My whole wave has to fit in between those 2 points right there. And we always start and end in the same place. So from there, right in the middle is 1. So that's going to be my midpoint. Okay, my midpoint always, for cosine, always is at -1. Okay, it's the weird one. Sine's the easy one to remember because they're all at 0. But when you're doing your endpoints, those are going to be at 1, and then your midpoint's at -1 for cosine. Now, halfway between 0 and 1 would be 1/2. That's where my quarter points, I guess I could say. Those are going to be where we're hitting 0, and now I've got this like really squeezed little thing, just like that. Okay? Again, nothing happened to our amplitude, so we're still just going from -1 to 1, and life is good. Okay, we got something similar going on here with y equals sine of pi over 3x. Again, our b here, our b ends up being pi over 3. So when we find our period, that's going to be equal to 2 pi divided by pi over 3. Well, that's just the same thing as 2 pi over 1, really, because it's like, it's like over 1. Times, and then we flip that fraction and multiply, so that'd be 3 over pi. So that's going to be equal to, well, 2 times 3 is 6, and then a pi divided by a pi, that's going to be just gone. So that's going to be just 6. So our period actually ends up being 6 again. So again, we want to use that convention where, same just with like the y-axis, where every other square is 1, we're going to do every other square is 1 as well for our x-axis, because we can just kind of like fudge it. We're just kind of like, okay, you know what? It's close enough. Pi is about 3. We'll just roll with it. We'll call it good. So we'll make sure we scale everything like we always do, and then we will go ahead and graph. So sine, again, sine always starts at 0, ends at 0, and the midpoint's at 0. So we start at 0. Now my period's 6, so I got to make sure I end at that period of 6. And then, so then my midpoint in between 1 and 3 would, 1 and 6 would be 3. So that's where my midpoint's going to be. And then sine in between. So now we can do the in-betweens. Sine in between the first half, so the first quarter is always going to be at 1. So that one can go right there, right in the middle. It'll be 1.5. And then down here at 4.5, between the second half or the third quarter here, we'd have down here at -1. So it goes up and then down and then back. And that's how it would look. That one looks an awful lot like, if you flip back in your notes, it looks an awful lot like what we'd graph with just a normal sine function. And that's true because we've kind of fudged it to where 6, we say, is kind of equal to 2 pi. And so we kind of just fudge it so that it works out. This is why we use the scaling the way that we do and tell you to do it that way. Okay? My range is from the same way. Excellent. There you go. Good work. Keep it up.